Our next fun sheet, guys, is going to be on standard 9.6, and this standard says that we are going to compare the particle arrangement and type of particle motion associated with different states of matter. So there's a couple things that we need to know up front, and of course that first thing would be that of what state of matter means. So let's go ahead and type that out. So when we talk about what states of matter are, they are the physical forms in which a substance exists. And there are 4 of them. They're going to be, of course, solids, liquids, gases, and the not so much known plasmas. Before we move on too much further and talk about the individual states of matter, we need to remind ourselves about these particles. Remember that these particles that they're talking about are atoms, okay? So it says matter is made up of particles or atoms that are, there's 2 things that we need to pay close attention to here, okay? They're always in motion. Even in a solid, when you think something is frozen and it's not moving, at the atomic level, those particles are moving. So they're always moving and constantly bumping into each other. So it's sort of like they're vibrating in place, and then as you add more heat, of course, they're going to increase in how much they bump together. So the next statement that we're going to say here, number 2, is that they move faster at higher temperatures and vice versa. So now we're ready to look at the 4 different states of matter, and remember, we're focusing on how the atoms or the particles are arranged, as well as how they are moving. Those are the 2 things that we're going to focus on. So first of all, with a solid, if you look at that picture over there, you can see that they're in a nice orderly arrangement. They would actually be slightly moving. We'll actually be drawing this here in a little bit. So what I want you to write for arrangement is that the particles are in a tight and orderly arrangement. For their movement, while you can't see this picture moving, of course, what we need to write for that is that the particles vibrate in place. And I always like to think about this, when I'm really cold, I sit there and sort of shiver. And so that's the idea of those, as I get colder, I shiver, and that basically is that movement that takes place as long as there is temperature around. Now, with liquids, okay, as we add energy to the particles, and you think about as you add energy, that would be in the form of temperature and heat. As we add heat to these, what they will do is start warming up a little bit. Sort of like your own body, as you start running, you get warmed up and your muscles become looser, and that's exactly what happens with the particles in a liquid. So particles are more loosely arranged and have some empty space. So if you look at the picture to the right, what you see is that these particles are not in this nice crystalline cubicle type feature, that they are moving around, sloshing around. You think about something inside your glass, those particles are moving inside of there, and it's because they are in the liquid state, meaning that they have a little bit more heat added to them. So once again, when we talk about their movement, particles can slide past each other, and that's why we're able to actually pour something from one cup to another, and etc. Our third state of matter is going to be gases, and if you look at the picture to the right, you can see that they are not in a nice orderly pattern anymore. There's a lot more empty space in between them, and those arrows are showing that they are moving very quickly, and that's exactly what happens as you add more heat. Okay, so when we talk about their arrangements, basically describe what you're seeing over there in the picture. Particles have a lot of empty space between them. And their movement is pretty erratic, because at this point, it's sort of like when someone says you're bouncing off the wall. That's literally what they are doing. So the particles are moving very fast and bounce off of each other. And of course, the more heat that they have, the faster that they're moving. And this is why I gave the example one time in class with a balloon. What happens when you take a balloon that's been filled up inside of a store where it's, cooler outside on a hot summer day, you take it out and sometimes those balloons pop. It's because those particles start moving faster and faster and faster, hitting the inside of that balloon harder, and therefore it ends up popping. Okay, here's the first place we're going to put some symbols. So if your first name starts with A through G, this is your first name, you're going to circle the word gas. If your first name starts with H through O, you're going to circle the word liquid. And if your first name starts with P through Z, you're going to circle the word solid. Let's move on to our fourth state of matter, and that would be plasmas. So plasmas are a little bit more difficult to talk about because we don't have a whole lot here on Earth. And the reason that we don't have a whole lot here on Earth, we're going to write this down next to plasma, it's rare because Earth is so cold. And because Earth is so cold, our temperatures just don't allow plasmas to happen naturally. We can have some artificial forms, and we actually have some natural forms of this, but it is not as consistent as we see our solids, liquids, and gases. So when we talk about particles and how they are arranged, in this case, the particles have completely broken apart. Okay, and so when we talk about this, this gets a little bit more complex with the atom and everything, but that's exactly what has happened. The electrons and protons have separated. We don't need to go into that detail, but that's basically what is going on. With a movement, they are the fastest of any of the different states of matters. So particles are moving very, very, very fast. This has the most heat of any of the states of matter, and thus why they are moving that quickly. Since these are not that common, and you probably haven't heard about this all that much, I'm going to give you some examples of these, unlike the others, which we should know examples of solids, liquids, and gases. So examples in the natural form that we have here on Earth are lightning, the sun's rays, and the northern lights. And that's the picture that I have over here on this particular screen. It's not on your paper, but on my screen. That is a picture of the northern lights, and we'll talk some more about that in class. But those are natural forms, and remember, it takes a lot of heat to allow that to happen. You think about lightning, and there you go. Artificial forms that we make here on this Earth, basically you can run electricity through a plasma and get it to glow, and that's exactly what we have with fluorescent lights and neon ensigns. So let's look at the picture that we have here at the bottom of your paper. We look at the three different states of matter, and with the red arrows, if you notice how it goes from a solid to a liquid and liquid to a gas, you add energy. And of course, this energy that we're talking about is heat. So what I want you to type here is that as temperature increases, so does the particle movement. And remember, we're talking about atoms here. Until it overcomes this force of attraction. And we'll talk more about this force of attraction as we get talking more about atoms. But this force of attraction actually holds the particles together. And this goes in the opposite, so I want you to write vice versa here as well, because if you look at the blue arrows and we go from a gas to a liquid and a liquid to a solid, then as you remove energy in the form of heat, then you're going to change the states of matter, and those particles begin to slow down and become more orderly and more neatly arranged, as you can see in that solid, where you have a little bit of vibration. They're in a nice orderly pattern, and in the middle, those liquids have some movement as well, and there's a little bit more empty space between them. So it really gives you a good feel for what we need to know right here as well. At this point, I want you to look at the very first page that we have just gotten done with, and in the left margin next to all the definitions that we just did, I want you to draw an arrow starting from the word solid all the way down to the word plasma. Okay? And then I want you to write increasing in energy. So if you didn't hear that, that was the words increasing in energy with that arrow. Now, on the back, what we're going to do is I am actually going to have you guys draw some pictures here, and I'm going to draw those with you just to make sure that you're doing that how we need to. But it says to draw a picture of each state of matter that show the particles or atoms arrangement, and then I want you to add the movement. I want you to write some words about how they are actually arranged there. So we're going to draw some circles that represent the atoms or the particles, and I'm going to draw them really close together. And this isn't turning out exactly how I want it to, okay? They should be touching. And I know this is not how it should be, but this is about as close as I can get it. And so we want to draw those particles touching in this nice, orderly fashion. And also what I want you to do, so you can repeat a couple of rows of that, 3 or 4 rows, and then I want you to add just some of these little wings almost, just like they're sitting there vibrating in place, okay? So there is vibration to them. There's not a lot of movement, but there is slight movement, okay? That just shows that they are moving, okay? Now, don't forget also that we need to, I want you to write the arrangement of them, okay? And so if you go back up and look at your notes, that's what I'm wanting you to write there. Now for a liquid, what we're going to draw here, these particles are a little bit more loosely arranged. I'm not going to use a circle method because that didn't work too well a little while ago. But they are not touching as much. They can touch and they can overlap, because remember we said that they could slide past each other, but there is no neat and orderly arrangement here. So I just want you to draw some of these circles, and then of course we also need to draw that they're moving as well, okay, but they're not just simply vibrating in place. So there is slight more movement here, and they are moving around more than the others. Okay, now for the particles of a gas, we are going to show how these things are randomly moving. They're a whole lot more spaced apart, and that they can be going in any given direction. There is no particular movement. They're not just sloshing around in place. They're moving and bumping into each other at all given time. So this is basically what you need to write or draw, and then write how they are arranged, okay, looking back up at your fun sheet that we just wrote some notes about. Now, for the last thing that I want you to do with this picture, you have 3 different materials here with material A, B, and C. I want you to locate the picture that looks most like that of a gas, and I want you to write a letter G over that picture with that material. For the one that most looks like a solid, I want you to write a letter S over the picture that shows a solid. And for the picture and the material that looks like a liquid, I want you to write a letter L over that picture. And this is the end for the fun sheet on 9.6. Have a good Thanksgiving break, guys.